My name is Yuta Uchiyama from Kobe University. The title of my presentation is Beekeeping and Transmission of Traditional Knowledge. And introduction. The ecosystem services of pollination is one of the major ecosystem services categorized in regulating services. And these services are provided by the interaction between bees and other insect and animals and human interventions. The problem is decline of pollinators and related pollination services. The main cause of this problem is our rapid land use change, climate change, expansion of invasive species and diseases. So the challenge is identifying mechanisms of the expansion of the diseases and proper intervention with relevant knowledge to prevent the disease. In the international process of conservation of biodiversity and ecosystem services, especially in IPBES, they're producing this kind of reports and showing that the impact of the pollination services is very significant in the different sectors, including agricultural sectors. So for the traditional forest related knowledge, contribution of TFK or pollination to sustainable forest management is discussed in existing literatures. This is a paper of Professor Park and Professor Yun in 2012. And for the history and the current trend of beekeeping in Asian countries, this is a case of Japan and South Korea. And this is a paper of Professor Kohsaka, Professor Park, and me. He published in 2017. The trend of apiculture in Japan. The production of bee honey is gradually increasing, although the aging of pollinators are getting more serious issues. And there are various methods of small-scale beekeeping. For example, for the left side, this is a picture of urban beekeeping in Tokyo. They are doing pollination on top of the buildings using this kind of garden. And they are promoting environmental education as well as production of bee honey. And this is a picture taken in Nagano Prefecture in winter. The pollinators are using different types of materials to make this kind of facility for bees to provide the comfortable environment for them. So the research site and data. The site is Nagano Prefecture, which is well known as the largest production area of bee honey in Japan. It has diverse topography, and the beekeepers can conduct beekeeping for a relatively long time in a year by moving the beehives from lower elevation area to higher elevation area and going back to the lower elevation area. And we conducted questionnaire survey, especially focusing on information channels and productivity of bee honey. The respondents of this questionnaire are members of the Association of Beekeepers in Nagano. The survey period is from February to March in 2017. Analysis method. We focused on the relationship between the productivity of beekeeping and information channels. And chi-square tests were performed to identify the statistical significance between the relationship. And we categorized the respondents into two groups by using the median of indicators or productivity. Specifically, one group with higher values of the indicator and the other group with lower value of the indicator. The indicator related to productivity are listed here. Result. The age of more than half of the respondents is over 17 years, and 94% were male. The aging rate of Nagano Prefecture is relatively high, reflecting the national trend of aging in rural areas. This is a context of this study site. And the head of household are usually in rural area in Japan, usually male in rural area in Japan. So I think this is the reason why the percentage of male respondents is relatively high in this survey. So the figure here shows the overall trend or percentages of respondents with different information channels. This figure shows 90% of respondents obtain the knowledge from parents or relatives, and 56% of respondents obtain the knowledge from friends. And the last, this 15% of respondents obtain the knowledge from self-learning. So we categorize them into two groups using the median of individual value, individual indicators. And so after the categorization, higher groups is like this, and the lower groups status is shown in the below. So for the number of bee colonies, statistically significant difference between higher and lower group is detected. So as shown in the figure, the higher group, which has larger number of bee colonies, tend to obtain the knowledge from parents or relatives and self-learning. And the lower group, which has relatively small number of bee colonies, tend to obtain the knowledge from friends. For the second indicator, share of beekeeping in household income. The significant difference is detected for this indicator too. And the higher group, which have higher share of beekeeping in household income, tend to obtain the knowledge from self-learning. And on the other side, the knowledge obtained from parents and relatives may not make the households specialized in beekeeping. And for the indicator of years of experience and years after obtaining the relevant knowledge, there are similar trend for both indicators, and statistically significant difference is detected. As you can see in the figure, the respondents who have relatively longer year of experience and longer year after obtaining the relevant knowledge tend to get the knowledge from parents and relatives. So this result shows beekeepers whose parents or relatives are beekeepers can obtain the relevant knowledge at a younger age. For the fifth indicator, which is the the method of the unique ecological method. There is no significant difference for this indicator. So the results show the effort to develop unique ecological method for beekeeping were observed across all respondents. Summary. The information channels influence beekeeping productivity, including number of bee colonies and household income shares from beekeeping. For example, the respondent who obtained the knowledge from their parents or relatives had a relatively larger number of bee colonies. There are some challenges. To open the knowledge transmission channels beyond families is one challenge. And the other one is transforming the knowledge from tacit knowledge among limited members to an explicit manualized knowledge. So for these challenges, so the Japanese government is collecting tacit knowledge of experts using information and communication technologies, ICT, for future reference and to protect the knowledge as intellectual property. So this kind of technology can be used to address these challenges. Thank you for your attention. And this is a paper which has more detailed results.